sometimes we're given kind of a bit of a word problem and asked to write an equation of the quadratic. So I just want to remind ourselves of y equals ax minus p squared plus q, where p comma q is the coordinate of our vertex and a is our stretch factor. Okay, so if we come to a question like this, we can fill in some gaps here. It says the vertex is at 2, 1. So that means if I were just to fill in what I know, I would say y equals, I don't know what the stretch factor is, but I do know that it'll be x minus 2, because that's my p, squared plus 1. And now if this was negative, I would say minus 1, but it's plus, so it's plus 1. So that's actually a lot of information already, which is really great. I also know that, so this is just substituting vertex. I also am given a point. So I can solve for my a in the equation because I know that when x equals 3, y equals 4. So what I'm going to do is I'm just going to highlight different colors and substitute. So y, which is 4, equals a times 3 minus 2, because I'm substituting in for my x, squared plus 1. I'm just going to use these same colors. I used 4 because that's the y value of the point given. And I'm going to use 3 because that's the x value of the point given. So now I just have one equation and one unknown, so I can solve for it. So I'm going to do what's in the brackets first. 4 equals a. 3 minus 2 is just 1 squared plus 1. So then I have 4 equals 1a, which is just a plus 1. I'm going to subtract 1 from both sides. 3 equals a. So now what I can do is I can substitute that value of a in for my a value, and I will have a full equation. So the equation is y equals a, which is 3, x minus 2 squared plus 1. Done. This one does not have the value of the vertex, but it kind of gives us a clue as to what the vertex is. And another great thing is that it gives us 2 points to substitute in. So let's just fill out what we know. So I'm going to write down y equals a, x minus p squared plus q. Now I know that my p is going to be -1. So I'm going to say y equals a, and then since I'm going to have to substitute it in, I'm going to use my square brackets, x minus -1 squared plus q. Now I have a few more unknowns than I'm comfortable with it, but let's first fix this up. So y equals a x plus 1 squared plus q. So the next step here is going to be substitute both points in. And then use substitution from last year in grade 10. To find the unknowns. So what I'm going to do is I'm going to say for point A, my y, I'm going to use highlighters here because I think that they're really helpful. My y is 3, and my x is 0. So I'm going to say y, which is 3, equals a, which I don't know. X is 0, so 0 plus 1 squared plus q. I don't know what that is, but we are going to highlight it so you know where it's all coming from. The 3 is because our a is 0. Sorry, the 3 is because our y value of our point is 3. And we use 0 for our x because that's the x coordinate that of the point that's given. So if I clean this up a little bit, I'm going to say 3 equals 0 plus 1 squared, so that's just 1 squared, so that's just a plus q. And for point B, now I'm just going to put this because I'm going to have to reuse a color. I'm going to have to reuse green. So -3 is our x-coordinate and our y-coordinate is 9. So what I'm going to do is I'm going to substitute the second point into the equation. So I'm going to say 9 equals a, then my x is going to be -3 plus 1 squared plus q. So again, I'm just going to highlight. I said -3 because that's my x, and I'm using 9 because that's my y-coordinate. So what do I have here? I'm going to just as I clean this one up, I'm going to clean this the b one as well. So a equals -3 plus 1 is -2. -2 squared is 4, so 4a plus q. So here's the thing. If I were to set both of these equations equal to q, so that means if I subtract a from both sides in this original equation, the a, so I said 3 minus a equals q. And if I were to isolate the q in this one, so 9 minus 4a equals q, I have two expressions that both equal q. So what I can do is I can set them equal to each other. So isolate q and then set expressions equal to each other, and then solve for a. So I'm going to say 3 minus a, so 3 minus a equals q, but q also equals 9 minus 4a. So I'm going to keep it positive. I'm going to add 3. Sorry, I'm let the cat out of the bag. I'm going to add 4a to both sides. So then that comes out to 3 plus 3a equals 9. So I've just added 4a to both sides. I'm going to subtract 3 from both sides here. So 3a equals 9 minus 3 is 6. So that means that our a is positive 2. So what does that mean? So I'm going to zoom out a little bit because we've actually done quite a bit of work. So I know that this right here is our equation. In order to have a full equation, I need to have my y value, or I need to have my y and x variables, but I need to figure out what a and q is. So if I were to fill in what I know, I'm just going to take a little bit of a break just to regroup. So y equals a, which is 2, x plus 1 squared plus q. We still need to solve for our q. Luckily, we have two equations that help us solve for 2. We can either use q equals 9 minus 4a, or q equals 3 minus a. Now, q equals 3 minus a is smaller. Okay, they use smaller numbers, so that's the one I'm going to use. So I'm going to say q equals 3 minus a. But I know that my a equals 2, so I'm going to substitute 2 for that. So then q equals 3 minus 2. Q equals 1. So now, finally, I can write my full equation. Y equals 2x plus 1 squared plus 1. And that, my friends, is my final answer.